As we know, the Mars is the fourth planet from the Sun. Mars is one of the most explored bodies in our solar system. As the population of humans is rapidly growing, scientists want to explore the other planet, which is Mars, that is believed having a potential for living. Based on the previous discovery, there is a part of the area in Mars was once flowed with water and was home to an ancient river delta. So it proved there is a presence of the oxygen, but its concentration is not sufficient for living. In this mission, we aim to send a rover together with scientific instrument by our high-class rocket, which is called a swift chain rocket. Our swift chain rocket generates thrust using a controlled explosion as the fuel and oxygen undergo a violent chemical reaction. Expanding gases from the explosion are pushed out of the back of the rocket through a nozzle. The nozzle is a specially shaped exhaust that channels the hot, high-pressure gases created by combustion into a steam that escapes from the back of the nozzle at hypersonic speed, more than 5 times the speed of the sound. When our rocket is successful to escape from the gravitational force of the Earth, the solid rocket booster will break away from the body part of the rocket. After that, our L10 engine of the swift chain rocket will start to operate to produce a thrust toward to the direction of Mars. There was 3 Newton's law has been applied by our swift chain rocket. The first one is Newton's first law. In rocket flight, force become balanced and unbalanced all the time. A rocket on the launch pad is balanced. The surface of the pad pushes the rocket out while gravity tries to pull it down. As the engines are ignited, the thrust from the rocket unbalances the force and the rocket travels outward. And the second one is Newton's second law. Newton's second law of motion is useful when designing efficient rockets. Newton's second law of motion can be restated in the following way. The greater the mass of the rocket fuel burn, the faster the gas produced that can escape from the engine. The greater the thrust of the rocket, since the combustion of the fuel produces a thrust force that exceeds the centripetal force, the acceleration of the rocket started to increase continuously over time. Therefore, the rocket will achieve the maximum speed to escape from the gravitational force of the Earth. Furthermore, the third law is a Newton's third law. A rocket obtains thrust by the principle of action and reaction. As the rocket propellant ignites, it experiences a very large acceleration and exits the back of the rocket. At a very high velocity, this backward acceleration of the exhaust exerts a push force on the rocket in the opposite direction, causing the rocket to accelerate forward. There were a few theories has been applied by our swift chain rocket. The first theory they apply in rocket structure is the design of the rocket has to be a lightweight structure, and at the same time, it must be strong enough to withstand the tremendous thrust of the engine during liftoff and to transfer the vehicle in a balanced way without damaging the vehicle. Strong material with lightweight which are suggested to be used such as aluminium alloy and composite. Besides that, let's talk about the theory they apply to the rocket part. No matter the size, all rocket must have a body. This section holds many of the electronics needed to control large rocket. The aerodynamic shape of the nose cone helps prevent air from slowing the rocket. In addition, aerodynamic force is also one of the theories that applied by our swift chain rocket. Furthermore, conservation of momentum was also applied by the rocket. A rocket moves in space because the gas are given momentum as they are expelled by the rocket engine.
The launch abort system is positioned at the top of the payload fairing. It can activate in milliseconds to pull the spacecraft away from the rocket if a problem arises during launch or ascent. The system's powerful abort motor can accelerate from 0 to 500 miles per hour in 2 seconds if needed during an emergency. Sub-satellites. They are small, low-cost science and technology experiments called CubeSat, which will be deployed into deep space and Mars from the payload fairing. Payload ferry, powerhouse that fuels and propels the spacecraft in space. It provides propulsion, thermal control, and electrical power generated by solar arrays. On missions with astronauts, the service module will also provide life support system for the crew, including water, oxygen, and nitrogen. RL-10C1 engine. This engine uses liquid hydrogen and liquid oxygen and can provide up to 22,300 pounds of thrust. It has provided precisely controlled, reliable power for planetary exploration. Centaur interstage adapter. It connects the first stage of the Swift champ with its Centaur upper stage. Centaur. The Centaur second stage is 10 feet in diameter and 41.5 feet in length. It is propelled. Tanks are constructed of pressure-stabilized, corrosion-resistant stainless steel. Centaur is a cryogenic vehicle filled with liquid hydrogen and liquid oxygen. Common core booster. Centerpiece of the first stage is the common core booster, 106.5 feet in length and 12.5 feet in diameter. It has throttleable RD-180 engine, thermally stable kerosene fuel, and liquid oxygen is loaded shortly before launch into cylindrical fuel tanks that make up about half of the total height of the vehicle. Solid rocket booster. Swift champ rocket has two solid rocket boosters strapped onto the common core booster add to the thrust that is produced by the first stage. Each this booster is 64 feet long and 61 inch in diameter, and it delivers 306,000 pounds of thrust. RD-180 engine. This engine has two thrust chambers. It packages the high performance, operability, and reusability features of in size to meet the propulsion requirement for the Swift champ rocket. Launch pad. It has the infrastructure to support the system and to launch Swift champ rocket. First scientific instrument is the Mars Propulsive Rover. The rover is a six-wheel vehicle loaded with cameras and science instruments. It is designed to be mobile in order to explore the Martian surface. Second scientific instrument is the Mars drone. It is a small helicopter that flew to Mars aboard with propulsive rover. It helps scientists search for interesting geologic features and visit locations that neither rover nor human can reach. Third scientific instrument is the Mars Potato Farm, a set of experimental instruments to grow potato on Mars, which will be carried out by the rover's body. This experiment will study the minimum condition for potato to grow in challenging Mars conditions. Fourth scientific instrument is the Purposeful Passenger. A suit mannequin named Commander will occupy the commander's seat to provide data on what crew member may experience in flight. The mannequin seat will outfit with two sensors, one under the headrest and another behind the seat. It is to record the acceleration and vibration throughout the mission. The fifth scientific instrument is the Cube Champ. In conclusion, the Roket MASCAR 2025 mission is demonstrating key technologies for using natural resources in the Martian environment. The scientific goal relates to the national space policy for sending humans to Mars in the 2050s. Similar to the history of the exploration of Earth's moon, Roket MASCAR 2025 mission to Mars provide a crucial understanding of the environment and test innovative technologies for future human exploration.